Greetings. In last lecture, we deal about the strain energy concept under the action of forces like shear force and torsional force. In today's lecture, we will be dealing with basic concepts or basic theorems of structural analysis. Let's start with the work done by a force. For that, let us consider a member AB subjected to force W at C, which is going to cause a deflection diba. Let us picturize this one. Let us say A and B is there and it is going to supported by a knife edge, because I talk about simply supported beam here, having developing a reaction Ra and Rb at the ends. At the point C, within the span of the beam, there is a loading W. This loading is going to cause the deflection of the beam, which is amounting a value about diba. Now I want to know what work done is being there during the deflection by this force. The work done by the force will be 1/2 of W into diba. This force is applied gradually. That's why we have to take the effect of this force as an average effect. That's why 1/2 of W into diba I will consider here the total work done. That's the force multiplied by the total displacement which has been caused by this force. Okay, now let us extend this concept for the case where there are two forces which are going to be playing on the span of the beam, and let us consider here the force W is going to cause a deflection of the beam. So if I want to know the deflection of this beam, let us say W is going to have deflection of Y on this beam, then the work done by the force P will be equals to, now deflection is being caused by W and this deflection is simply observed by P without an action. Then what will happen? Simply this force is going to have a deflection causing a work done equals to P into Y, whereas the action is being played by the force W, which was gradually increased to cause the deflection. The work done by this force will be 1/2 of W into Y. So this is a simple difference. When the force is under action, we are going to consider average force multiplied by the displacement. And simply the force is being in a displacement system, then it will cause a work done which equals to product P into Y, force into the displacement observed by entire system here. Let's extend this concept with the law of reciprocal deflection or Maxwell reciprocal deflection theorem. What the theorem says: in any beam or truss, the deflection at any point D due to load W at any another point C is the same as the deflection at C due to the same load W applied at D. What is going to happen here? He says that if I am going to apply a force at a point D and I am going to observe the deflection at any other point C within the span, the deflection caused at this C will be same if I change the position of the loading. Now the position of loading is here, load is applied at the C and he is going to observe the deflection at D. So he will have the same deflection as it was applied in the previous case. Let's try to picturize this thing. Okay, so I will consider here a simply supported beam AB and two points along the span C and D. Firstly, I will consider W is the load which is going to applied at the C, causing a deflection delta C. Due to this, at the point there is certain D, there is certain deflection observed, and that deflection is delta D here. Okay, now what I will do, I will change the reversal of the action of the force here. Now I will say the force is being applied at W, which is going to cause a deflection here diba D, and due to this deflection the one more at point C there is a deflection observed. Let us say that deflection is diba C. According to the statement which has been given by Maxwell in his theorem, it says that the deflection observed at the point D and the deflection observed at the point C due to action of the load at any another point will be equal. So let us try to answer this concept with mathematical relationship. So let us have first work done by the load W at C will be 1/2 of W into delta C. If I am going to consider only the effect of force at the point C, it will be simply 1/2 average force multiplied by the displacement. Now if I say there is a there is a action of the second force here, now W which is being acting on D, and this is going to produce a distortion of delta D, okay, on this beam. Now what will happen here? I will have 1/2 of W delta C the first work done by the force plus 1/2 of W into delta D, the work done by the force which is applied at the point D, plus one additional work done will be there, because when the second force is going to be in action, the first one is being just observing that deflection, not doing any action there. So it will be W into delta C. The work done due to the virtue of displacement will be W into delta di by C. Okay, now I will reverse the things. Instead of saying that the work done is started from the point C, I am going to start with the application of the force at the point D. Then it will be 1/2 of W into di by D. And if I say the mutual action of the two loads at C and D, it will be work done by the another load W at C on the same system will be work done by another load W at C on the same system will be equals to 1/2 of W into di by D plus 1/2 of W into delta C, and this is the second force which is going to cause now distortion in the previous system. That's why additional work will be observed by the first force which was at the point D. It will be W into delta D. Okay, if I equate these two equation of reversal loading, what I will get? I will get di by C is equals to delta D. That's the proof for the statement which has been made by Maxwell in his reciprocal deflection theorem. Okay, now let's move towards the next case. This was extended further by Bettis with giving giving extension towards a set of loadings. The statement says that in any structure, the material of which is elastic and follows Hooke's law, and in which the supports are unyielding and the temperature is constant, the virtual work done by first set of loading P system during the distortion caused by the second set of loading Q system is equal to the work done by the set of loading Q system during the distortion caused by the first set of loading P system. Means what he says, the material is an elastic, means it has a deformation capabilities, but it follows the Hooke's law, means within the elastic limit. The supports are not having any yielding, means they are not going to sink, they are not going to settle down, and the temperature effects is also neglected. Okay, temperature is not going to create any extreme stresses in the member. Then in that case, the virtual work done by the first set of loading, let us say at this instant P system is that first load system, due to distortion, who is going to cause distortion for this work done? The distortion is being caused by the second load of system Q system, is equals to, if I reverse the situation now, work is being done by Q system and distortion is going to be done by P system, that is first loading set. So what will happen? The work done, the virtual work done by both the system will be equal. Let's try to get the understanding of this statement, and for that we will do some mathematical calculation here. Let us consider a simply supported beam is there, which is subjected to P1 P2 forces, representing the P set of the forces here, force system here, and Q1 and Q2 is the forces which are second set of the forces which are going to act, representing the Q system of forces here. So P1 P2 forms P system of loading, Q1 and Q2 forms Q system of loading. Let us consider there are the distortion caused by these forces. Okay, the Q1 and Q2, the set force is going to cause a distortion equals to x1 and x2, whereas P1 and P2 forces is going to cause a distortion y1 and y2. So x1 x2 are the distortion caused by the Q system, and y1 y2, it should be y2 here, y2 are the distortion caused by the P system. Now let us see what is happening here mathematically. According to a statement, P1 into x1, P1 is the first set of forces, but the distortion is being caused by the second. So P1 into x1 plus P2 into x2. This work done by the forces with reference to distortion of the second set is equals to Q1 and y1. Y1 is the distortion caused by the first set of the forces. That's why P1 Q1 into y1 plus Q2 into y2. So mathematically, if I want to write this statement, it will be written in this format. Now let us try to prove it. For that, I am going to consider here the first P1 P2 set of forces here causing distortion y1 and y2. and then the second one q1 and q2, the q set of the forces which are going to cause distortion x1 and x2. Now we be the work done by the structure when the p system of the forces is being applied. So we under the action of p force of system will be 1/2 of p1 y1 plus 1/2 of p2 y2. Similarly, if I go for we dash, which is the work done on the structure when q system of forces is being applied, then it will be we dash will be 1/2 of q1 x1 plus 1/2 of q2 x2. Is this a work done by the q force system? Now let the structure first be loaded with p system of forces, then work done by the structure is equals to, firstly if I am going to say the p system is being there, and under the action of this loading, the work done will be equals to we, means only single p system is going to apply here. Now let us q system of the forces is being applied. Then what will happen? The member will be subjected to additional distortion which is being caused by the q system of forces, and that distortion is the x1 and x2. Then the work done will be equals to 1/2 of p1 y1 plus 1/2 of the p2 y2 plus 1/2 of q1 x1 plus 1/2 of the q2 x2. This is the work done by p set of forces, this is the work done by the q set of the forces, plus additional work done by work done due to additional distortion for the p force system. It will be p1 x1 plus p2 x2. In similar fashion, if I reverse the loading, let's change the loading system here. Let the structure be loaded with the q system of forces, then the work done on the structure will be equal to we dash, and let now p system of forces has been applied, and this is going to cause a additional distortion which is y1 and y2. Then work done by the structure is equals to 1/2 of q1 x1 plus 1/2 of q2 x2 plus 1/2 of p1 y1 plus 1/2 of p2 y2. This is the work done by q system of forces, this is the work done by p system of forces, and due to this work done there will be additional work which will be observed by the q set of system for additional distortion q1 y1 plus q2 y2. Now equating both the side, what we'll get? We will get p1 x1 plus p2 x2 is equals to q1 y1 plus q2 x2. Okay, now we'll move towards one more statement or one more law here, that is said to be Castigliano's first theorem. According to this theorem, in any beam or truss subjected to any loading system, the deflection at a point R is given by the partial differential coefficient of the total strain energy stored with respect to the force PR acting at a point R in the direction in which the deflection is desired. In his statement, he wants to say, if I am interested to know what is the deflection observed under a particular load at a particular location, then what I can have, I will have partial derivative of the total strain energy stored during the work divided by with reference to the variable force where I want a deflection. If I put this in mathematical picture, let us say, let a structure AB carrying a load system P1, P2, P3, P4, that dash P1, PR, it's not P1, it's a PR up to Pn, means n number of forces going to act on my beam like this, and I am interested to know what is the deflection at the rth point of this one. For that, simply what I can have, if I am interested in to know the deflection at P for the caused by the P1 load, what I can do, total stored energy divided by, I will take partial derivative of total strain energy with reference to that load. I will make this load as a variable part. So I will do, y1 is equals to dou u upon dou P1. Here dou represents partial derivative of that particular. If I similarly I am interested in y2, so what I will get, y2 is equals to dou u upon dou p2, y3 dou u upon dou p3, and yn dou u upon dou p4, and yr dou u upon dou pr, which is the point of interest for me according to the statement. At any point where I am interested to know the deflection, what I will do, I will take the partial derivative of strain energy stored by that member with reference to the load, with respect to the load under which I am interested to know the deflection. Let's try to prove this with a extension. For that I am going to say, consider as a simple effect of P